Hi my friend, how are you? I am Joey from Joey's Tech, and in this video of Joey's Tech, we will be solving weighted job scheduling problem using dynamic programming. Now, if you have already done longest increasing subsequence problem, if you have already solved it, if you know how to solve it, then weighted job scheduling problem will be a piece of cake for you. If you haven't, then you can watch my video on longest increasing subsequence using dynamic programming, the link to which is here at the top of this video, or you can find the link to that problem in the description of this video as well. If you are watching the video of my channel for the first time, then I request you to subscribe to my channel and hit the bell icon, because that way you will get notified whenever I release new videos like this. And also, if you are preparing for tech interviews or job switch or make the understanding of algorithm robust, then subscription to Joey's Tech will be a very good idea for you, because you are going to learn a lot through these videos. Now let's move to knowing the problem, what actually the problem of weighted job scheduling is. So you are given 4 jobs with 3 pieces of information about them. So there are 4 jobs, and there are 3 elements attached to each job. So the first element is the start time, the second element is the end time of the job, and the third element is the weight of the job. So like I told you, there are 3 elements attached to every job. One is the start time, second is the end time, and third is the weight of the jobs. For example, here is our job 1. The start time is 1, end time is 2, and its weight is 50. We have job 2. The start time is 4, end time is 5, weight is 20. Job 3, start time 7, end time 15, weight is 100. And last but not the least, we have job 4. The start time is 3, end time is 90, and the weight is 180. So in our operating system, multitasking is achieved through these jobs only. So these jobs are related to that only. Okay, now let's move to find out what is the problem statement. So the problem statement is that you need to find maximum combined weights of the jobs, the maximum combined weights of the jobs, which is based on one important condition, and that condition is that those jobs must not overlap with each other. Okay, if 2 jobs overlap with each other, that means their start and end time collide, then those jobs, the weights of those jobs cannot be added. They are not eligible, okay, to be considered as the candidates of weighted job scheduling problem solution. Okay, here is an example for you. So job 1 and job 2 are perfect candidates of which the weights can be added because their timings. So the timing of job 1 is it starts at 1, ends at 2, and the timing of job 2 is it starts at 4 and ends at 5. So they are not overlapping with each other. That is why the weights of these 2 jobs can be added. All right, now let's move to actually solving the problem. So here I am at the framework where we'll solve this weighted job scheduling problem. As you can see, I have listed the jobs here with their start and end time in this row, okay, and their respective weights in the row beneath. All right, now the first step, okay, to solving this problem will be to arrange these jobs in the increasing order of their start times. Okay, there are 2 reasons behind it. One, for the sake of clarity, and second, that it will help our understanding a lot if our solution progresses in the increasing order of the start times. Okay, how? Okay, it is going to make sense to you as we proceed with the solution. All right, so all I have to do, because job 2 and job 3 are already in sequence, all I have to do is put job 4 before these two jobs, like this. So we have job 1 with the start time as 1, job 4 with start time as 3, 3 is greater than 1, then job 2 with the start time 4, 4 is greater than 3, and job 3 with the start time of 6, okay, which is the highest. All right, now this is our array which we are going to fill with values, and this array only will give our solution. Now this is a dynamic programming problem, so each cell is going to represent the optimized solution of a subproblem, okay, that you need to keep in mind. Now let's talk about the base state. What initial values, okay, will be filled in this particular array? So I say that the values will be the weights of the jobs. So these are the base values, or you can say the initial values. Okay, why I did that? Now your question will be why I did that. Because at any point of time, let's say our weighted job scheduling problem consists of only this job, job 4. Then what will be the maximum combined weight be? It's obviously going to be 200 because there is no other job. So the weight of this job 4 is going to be the answer. Same here. If job 3 is the only candidate of our weighted job scheduling problem, then 100 is going to be the answer because we do not have any other job. So speaking of sub problems, okay, these are the base values of the individual sub problems. We can say like that. And this I have already explained in longest increasing subsequence problem. Now we are going to set our counters here. So J is going to be here, and I'm going to put I over here because this is the job from where it is going to start, because we already have the solution of the first candidate, which is 50. Okay, now we are going to compare, because our condition states that the two jobs must not overlap with each other. That is why we are going to compare the times of these two jobs. Okay, so does job 1 overlap with job 4? No, it doesn't overlap with job 4 because this job is starting when this job ends. It ends at 2 and this job starts at 3. All right, so these two are eligible candidates. So what we are going to do, we are going to add this 50. Okay, this is the optimized solution of this subproblem. So this 50 will be added to this 200. Okay, so 250 is going to give me 250. Now I'm going to compare that 250 with the value here, which is stored for job 4, the base value. Since 250 is greater than this 200, hence I will replace this 200 with 250. Okay, and I'll move on. I will move the counter of I one step to the right. Now I'm going to compare this job 1 with job 2. Okay, do they overlap? They don't overlap. So what I'm going to do, 50 is going to be added to this 20. The result will be 70. Is 70 greater than this 20? Yes, it is greater than this 20. Hence 20 will be replaced with 70. All right, we are going good. Now this J is going to be moved one cell to the right. All right, do these two jobs overlap? Yes, they overlap because the range is big, 3 to 100, and 4 to 5 already fall in this range. The job 2 already falls in the time range of job 4, hence they are overlapping. So this iteration won't be considered. All right, so J goes back to its base position and I moves one cell to the right. Okay, and this is our last job. Now, does job 1 overlap with job 3? No, it doesn't. So 50 is going to be added to 100. So I'm going to get 150. 150 is greater than 100. So 100 will be replaced by 150. Now J moves one cell to the right. Check this out. Job 4 overlaps with job 3. Hence this iteration will not be considered. Okay. So J moves one cell to the right. Now, do job 2 and job 3 overlap? No, they don't. So this 70, which is the optimized solution of the sub problem till here, okay, will be added to this 100. I'm going to get 170 as the answer. 170 is greater than 150. So I will replace 150 with 170, and that's it. That's it. Our iterations are now complete. Now, the last step is going to be that I will traverse this array to find the maximum value of this array. Now, as far as I can see, the maximum value is 250. 250 is coming as the maximum value, and this is our answer. So this is the maximum combined weight. And how I got this weight? I got this weight by combining the weights of job 1 and job 4. I already got 170 by combining the weights of job 1, job 2 and job 3. But as you can see that this weight, this combined weight is not greater than 250. Hence our candidates are job 1 and job 4, and this is our value. I'll create another video on finding the exact components of the maximum combined value of the weighted job scheduling problem. Okay, so need not worry. In that video, you will learn to find the exact components of the weighted job scheduling maximum combined weight. Now let's move to finding the algorithm. So this is our algorithm. Here is our super duper condition. If timings don't overlap, then Ti, which is the array, T represents our solution array. Ti is going to be max of Ti or Tj plus weight of I. The time complexity of this dynamic programming solution is going to be O(n) square. So with this, we have come to the end of this video. Okay, I hope you liked this video. If you liked this video, then hit the like button. I'll love to read your comments about this video. Okay, I'll see you in the next video of Joey's Tech. Thanks for watching this video. Goodbye.